Hello everybody. In this video we are going to pick up where we left off with the June 2023 Algebra 2 Regents exam, question 33. So I'm just going to scroll down to question 33. 33 is the first part 3 question, and now all questions are worth 4 points each. So once again, the same spiel I gave you in the last video for the part 2s. You want to make sure you're showing all work, all formulas, explain when you need to explain, make sure you are clear about all of your work, plugging stuff in, show every step to make sure you don't lose any silly points. Okay, let's jump right into number 33. So 33 says Patricia creates a cubic polynomial function p of x with a leading coefficient of 1. The zeros of the function are 2, 3, and -6. Write an equation for p of x. So an example of a silly point, I actually am not sure if it was a lost point on this one, but it specifically says to use p of x. So don't do something like y equals. You don't want to lose any points for those types of silly things. Again, I don't remember for this example if they took off for that, but that would be a silly thing. If it's saying use p of x, make sure you use the letters it says, okay? So I'm going to start by writing p of x equals. So now I have to write a cubic polynomial function with a leading coefficient of 1. The leading coefficient just means there's going to be a 1 in front here. So I have that 1, and then it gives me the zeros. Remember, zeros is another word for roots, is another word for x-intercepts, but the whole idea of zeros is that that is where the graph's solutions are. So if the solutions are x equals 2, x equals 3, and x equals -6, what you have to do is untee that up to figure out what the factors were. So the factor that would get me an x equals 2 is x minus 2, because if you write it out, x minus 2 equals 0, add the 2 to both sides, you get 2. So the rule is that always works is you just change the sign. So -6 would be x plus 6, and +3 would also be an x minus 3. So I'm going to write out the factors, because that'll end up being my equation that'll get me those roots. So next to this, I'm going to put those exact factors, x minus 2, x minus 3, and x plus 6. And this is actually going to be your answer. There's nothing more that you have to do. If the direction said to write your answer in standard form, you'd have to multiply these out, multiply this to that, and get that all multiplied through. But there's nothing extra to do for this because it did not say that. It just said write an equation, and we're good. Now, I'm all about showing you how to check your answers as well, especially if you finish the exam early and you have extra time at the end. Of course, you should be checking and not putting your head down or anything. Okay, use all of your time and use it all wisely. So if I want to make sure that the roots or the zeros are 2, 3, and -6, I'm going to graph it. So I have x minus 2. I didn't type in the 1 because it won't change anything. You can type in the 1, but again, it won't change anything. Okay, so that's the equation that I came up with. When I hit graph, I notice it crosses the x-axis. Look, at -6, at 2, and at 3. And those were the 3 places it was supposed to cross the x-axis. So we are good. It checks out. It was a quick, easy check. Now it says to sketch it on the axes below. So we should know how to sketch it by looking at it. We can use our resources. I'm going to show you how you should sketch it by just looking at it. Remember, there is a 0 at 2, 3, and -6. So I should put zeros at -6, at 2, and at 3. Now, we also need to know what a cubic function looks like. Cubic functions go up, down, or down, up, down. But because this one has a positive coefficient of 1, I want it to go up, down, up. So to follow through the points, it's going to have to go up first, then it goes down, then comes back up, and that's your cubic function. Now again, we do have a calculator and we can use our resources. You can literally type this into your y equals. I already did. Hit graph and make yours look like that. Up, down, up. It's even showing you on the calculator what the shape is. A very, very fair, in my opinion, question for a part 3. Okay, moving on to the next one, 34. So it says, this is a probability question. A public radio station held a fundraiser. The table below summarizes the donor category and method of donation. So looking at this two-way frequency table, just to refresh your memory on how to actually read the information from this table, if I wanted to know how many people, so about the donations, how many people made a donation from phone call as a supporter. So I would go phone calls, supporter, it would be this number. You're trying to find that overlap when it gives you two categories. So if I asked like patron category and the method of donation was online, I would find patron and online, and it's going to be that 2016 number. Now there is some information in this table that's not given that we will have to figure out as we do some of these questions, so I just want to talk about it. If you're asked how many total people use the method of donation as a phone call, the total people that used phone calls as their method of donation, you have to look at the supporters and the patron. So you would have to add both of these together to get the total amount of people that made their donation through phone call. Okay, so if you ever have to find a total, which we're going to have to, but that's how you would find it. If you want the total amount of supporters, you would add these two numbers together to get you the total down here. Sometimes the total column is given, sometimes it's not. All you have to do is add them together to figure it out. Okay, now for these two questions, we need our probability formulas. So for the first part, it says to the nearest thousandth. That is a huge hint that you're going to get a decimal. Find the probability that a randomly selected donor was categorized as a supporter given that the donation was made online. I see that word given. That is a keyword for probability. I'm going to write my given formula. Now the given formula is the probability of A given B. Remember, this symbol is given, equals the probability of A and B over the probability of B. Now, another thing we talked about in class is, yes, that's the formula to memorize with the A and the B so you know where everything goes. The given is like your new denominator. It's given this group only, so we're focusing on the donation being made online. That's going to be your given. So I don't care about anyone for this specific question that made the donation using a phone call. Again, we only care about online because that's the given. That's why that goes on the bottom. But it's a little tough to look at this formula and be like, okay, what topic is what? Where is everything supposed to go? So what we talked about in class is changing the letters. So find the probability that a randomly selected donor was categorized as a supporter. I'm going to call that S, given that the donation was made online, O. So I'm going to change it to S given O. You don't have to do this. I just think it's helpful. So then everywhere I see an A, I'm going to put an S. Everywhere I see a B, I'm going to put an O. So it's S and O over O. I think it helps to think a little less while you're plugging into the formula because now it's telling you on top, we need to find the number where the supporters and online intersect. So I'm going to go to the table. Supporters and online was 1,200. That's going to go on top with my and. Remember, this is the and symbol. On the bottom should be just the total of online. So for online, I'm going to go back to my table. I'm just going to uncircle this to show you. I need the total of everyone that was making their donation online. So that includes supporters and the patron. I want everyone that made their donation online to go in my denominator because that's the given. That's the group of people that we are looking at. So 1,200 plus 2016, goodness, is 3,216. I probably could have done that one in my head. 3,216. So that's my denominator. My 1,200 was on top, and now I'm just going to divide those. So I'm going to do 1,200 divided by 3,216. Again, I got a decimal, which is a good sign, so I'm going to write the whole decimal to show all of my work. Remember, you always want to write the whole decimal because if you don't write the whole decimal and you round it wrong, you have no proof of ever having the right answer. So write the whole decimal, and now I have to round it to the nearest thousandth. Thousandth is 3 places after the decimal point, which is going to be right here. But I look at this one, see if it'll bump that up. It will not, so my answer is going to be 0.373. Okay, so now for the next part, do these data indicate that being a supporter is independent of donating online? So there are 2 tests for independence that we learned in class. I'm going to show you how to do each of them. But again, this is an or situation. You do not need to do both of these. It's just 2 different ways that you could do this question. So the 2 formulas for testing for independence, one of them, and it's supporter and online. So I'm going to use the S and the O again. I'll just use the S and the O. So one of them is the probability of S given O equals the probability of S. That is your first test for independence. The other one is the probability of S and O. And if that's equal to the probability of S times the probability of O. Okay. Now you're testing if this is independent or dependent. We'll find out based on our answer. So we're not solving for anything in these formulas. We're plugging everything into them, and we're testing to see if they are equal to each other. Remember what we talked about in class? I know I keep saying that, but it's really important. Independent starts with an I. Identical starts with an I. If the left side is identical to the right side, that means that they are independent. If they are different, starting with a D, that's when they are dependent. Okay, just a way to help you remember. So if they're identical on the left and the right side, they'll be independent. If they are different, dependent. So now let's plug some stuff in. What's really nice about this one, and why I actually want to do this one first, this test formula, I should say, is because we already found the probability of S given O. We did it in that like part A. It was 0.373. I need to see if that's equal to the probability of being a supporter. So being a supporter in general for this question, it's kind of tricky. I'm going to erase what I have up here. But it's just being a supporter. So there's no overlap here. It wants the total for being a supporter. So I'm going to have to add these two together. That'll get me 1,600 when I add them together. So that means that there are 1,600 total supporters, but that's not your total on the denominator for this one. We're just talking about supporters. There's no other variable involved. It's just the probability of being a supporter out of everyone. So out of everyone, if I draw in my total columns, right, I have a total here, total here, total here, and total here. This box down here is the total, like the everybody. So to get that number, I'd have to add everything together. So I would do 400 plus 1,200 plus 672 plus 2,016. And that gets me a total, everyone in this entire table is 4,288. So that's going to go on the bottom, 4,288. Now, I have no idea if the left side is identical to the right side until I plug this into my calculator. So I'm going to do 1,600 divided by 4,288. And look at what I got. 373 equals 0.373. Now you should check that the whole decimal is the same. I'm just going to scroll up to show you that it is. We can also look up here. This whole decimal matches that whole decimal when I divided them. Now because they are identical, it means that they are independent. Make sure you answer the question. Do these data indicate that being a supporter is independent of donating online? You are going to say yes. Like sometimes it'll say, is it independent or dependent? This one just says, is it independent? So you're going to say yes. And then to justify your answer, we do have this work, but we have to explain this. So you're just going to say, because probabilities above are identical, are equal, whatever you want to write, anything along those lines. Remember, this was something different I was just showing you. Okay. So this is not relevant for this question at all because they were independent. Now that was just one way to do it. I think that way would be easier only because you already did the given up here. But if you want to do it using this test for independence, let's go for it. So we do have to find a bunch of probabilities, but let's go. It's good practice anyway. The first one is the probability of being a supporter and making the donation online. So I'm just going to erase my circle real quick. Okay. So for your and, you want to find that overlap. So a supporter and online is going to be this number right here. That's going to go on top. Now, this is not a given. This is nothing special. There's no special denominator. It's just the probability of being a supporter and making your donation online out of everybody. There's no given that they made it online. There's no given that they're a supporter. Like that's not a change in the denominator. This is everybody. So I'm going to use that 4,288 number again. And that's going to happen on the right side as well. So this one's saying the probability of just being a supporter. So for just being a supporter, it's still out of everyone. So out of that 4,288, there are 1,600 total supporters. Times, again, the next one is the probability of online. Sorry, I forgot the O. The probability of online. So that's still going to be out of the total, but now I need to find out how many total people made their donation online. So to do that, I'm going to have to add these two numbers again, and that'll get me my top, because that's the total people that did it online, which is 3,216. So now I can plug both sides into my calculator. We're trying to test to see if they are equal. So the left side, 1,200 divided by 4,288. gets me 0.279850746 blah, blah, blah. And then I'm going to type in the right side, 1600 over 4288. Nope, not minus. Times 3216 over 4288. And look at that, 0.279850746. A little sloppy, but I'm just going a little quick with writing that out. But they are identical, so this exact same answer is what you would write over here. The wording and your answer, yes, because they're equal, is the same. It's just whether you chose to use this test for independence or this one. Both will get you the correct answer. It does not matter which one you use. This one, like I said, was probably a little easier for this one because you already had that data from part A. All right, number 35, algebraically solve the system. Guys, every time you are solving a system, you have to solve for all variables. Please do not forget that. It's really tempting once you solve for x to be like, yay, I did it. Keep going, okay? So for this one specifically, what you have to do to solve it is plug one of your equations into the other one. So this one is already set up nicely because it's in y equals form. So since y is equal to negative 2x plus 7, that means I'm going to plug negative 2x plus 7 into my equation above for y. So that whole top equation is going to be rewritten. I'm going to write x minus 2 squared plus, but instead of y, I'm going to plug in what y is equal to in my other equation, negative 2x plus 7. But I still have to copy the rest of this, so that minus 3 squared equals 20 all comes down. So that's a really important first step, is just plugging one of your equations into the other one. It's called substitution. By plugging one of the equations into the other one, I can now solve the system for one variable. So if you look at the equation that I wrote in black, there's only one variable there, and it's x. So now I'm going to go through and solve this. So first thing I want to do is simplify this. So this is going to stay the same. I can combine like terms. That'll get me a plus 4. That equals 20. Now the next thing I'm going to have to do is take care of these squareds. Squareds means you have to write them out twice. So this one's going to be x minus 2 plus, negative 2x plus 4, and negative 2x plus 4, and that still equals 20. So this plus sign separates these. That means I'm going to multiply these together, and multiply these together. So the first one, x times x is x squared. Again, I use the shortcut, so this will be minus 2x minus 2x. This is kind of what's happening in my head. I just combine the like terms and get negative 4x. You do not have to do that. It just saves you some time. And then negative 2 times negative 2 is a positive 4. I'm going to bring down this plus sign and now multiply these together using that same thing. So negative 2x times negative 2x is a positive 4x squared. Negative 2x times 4 is a negative 8x. 4 times negative 2x is a negative 8x. If you want, simplify them right now. It gets you minus 16x. And then 4 times 4 is plus 16. That equals 20. Now there's a lot going on, but I have a bunch of like terms. So I am going to combine them. First, my x squareds will get me a 5x squared. Negative 4x minus 16x is negative 20x. And then 4 plus 16 is a positive 20. And that is equal to 20 still. So I've talked about this a bunch throughout all of the videos, but when you are solving something that has an x squared and an x, you have to factor it, and to be able to factor, you gotta be equal to 0. So I can't start factoring yet. I have to subtract this 20 over to get it equal to 0, and they end up canceling over here. So I end up with 5x squared minus 20x equals 0. To which I now have to factor. So it's not a trinomial anymore. We're not going to use trinomial factoring. This is going to be GCF. It's what you should always look for first anyway. So the GCF between these two terms is 5x. So I'm going to take a 5x and put it in front, and that'll leave me with an x minus 4 when I divide it out. Now when you're done factoring, and this does not factor again, by the way, so I'm done factoring, I'm going to tee it up. I get 5x equals 0, x minus 4 equals 0. So I get two answers here. One of them is 0, one of them is 4, and I'm done, right? No, I'm not done. I have to solve for all of my variables. So there was an x and a y in these two equations. That means that now that I have my two x values, I have to find my two y values. So now I am going to go up here, pick the easier of the two equations. It's definitely the bottom one. And I'm going to plug in these x values to that equation. So it's negative 2x plus 7. First, for x equals 0, it's going to be y equals negative 2 times 0 plus 7. So I get y equals 7. That means this answer is 0, 7. And I'm going to plug it into this one, negative 2 times 4 plus 7. That'll get me a negative 1. So this answer is going to be x comma y, 4 comma negative 1. And I just wanted to make sure, yep, that is the right answer. So I am done. Box it in. I solve for all variables. I am done. If you want to check your answer, I'm just going to keep bringing this up. Everything is helpful, especially if you have some extra time at the end. To check, you can take both of your answers and plug them into both equations. They're supposed to work in both. So I'm just going to show you the check for one of them. It's the same thing for the other. It is a little time consuming, but if you have the time, why not? So this is your x and this is your y. You're going to plug them into both equations. Of course, it works in this one because if I plug in a 0 for x and a 7 for y, I get 7 equals 7 and we're good. That's what we already used. The top equation, I'm going to plug in a 0 for x. So it's x minus 2. I'm going to write 0 minus 2 squared plus y is 7. So 7 minus 3 squared, and that should equal 20. I'm checking it into this equation, this top one here. So 0 minus 2 is a negative 2. Squared is 4. 7 minus 3 is 4. Squared is 16 equals 20. Why did I write plus? Equals 20, and you get 20 equals 20. It does check. You want to do the exact same thing with 4, negative 1. Plug it into this top equation, make sure it works. It's a little longer of a check than the other ones that we've done, but still not too bad, okay? It should work in both equations. All right, number 36 is formulas. On a certain tropical island, there are currently 500 palm trees and 200 flamingos. Suppose the palm tree population is decreasing at an annual rate of 3% per year, and the flamingo population is growing at a continuous rate of 2% per year. So we have two different formulas for these. The part A, like this first part here, says write two functions, p of x and f of x, that represent the number of palm trees and flamingos on this island respectively, x years from now. If you don't know what this word respectively means, it just means in order. So p of x is going to be the palm trees, kind of makes sense. F of x is going to be the flamingos. That's all respectively means, okay? So I do have to write two, and I'm going to use two different formulas. So for p of x, or my palm trees, when I go back up to the problem, it says the palm trees are decreasing at a percent rate. All it says is decreasing, and it gives a percentage. That's going to be your percent decay formula. So the formula is A equals P times 1 minus R to the T. It doesn't say compounded. It doesn't say anything fancy. It's just decreasing formula by a percent. That's the one. Flamingos is different formula. It says the flamingo population is growing at a continuous rate of 2% per year. If something is growing continuously, you have to use your compounded continuously formula, which is PERT. Remember, like we talked about in class, PERT is a brand of shampoo. We wash our hair continuously. Anytime it says continuously, PERT, shampoo. Okay? Now, even though the formulas say A equals, it's telling me to use P of X and F of X. So I'm going to, for palm trees, change that A to a P of X. For flamingos, change it to F of X. And now I have to plug everything in. So for palm trees, P is the first thing I have to plug in, which is the starting amount. If I read back to that first sentence, it says we're starting with 500 palm trees. So I'm going to put 500 there and then 1 minus. I'm going to keep reading about the palm trees. It's decreasing at a rate of 3%. So you have to convert that to a decimal by doing your scoot or doing 3 divided by 100 because percents are out of 100. Either way, you get 0.03. And then that's raised to the T in the formula, but be so careful. See right here where it says X, P of X, you have to use an X. So I'm going to change that T in the formula to an X. But I'm not plugging in a number for it because it doesn't give me anything to plug in yet. So that's just a formula to represent it for every year, and we'll use it to answer part B in a little bit. F of X starts with 200 flamingos, so that's going to go in for P. Remember, E is not a variable, it's a button on the calculator, so we do not plug in anything for E, but I do have to plug in for the rate. The rate is 2%, and I'm going to scoot to plug in my 0.02, and then again, not T. I'm not using T for this question. It tells me to use X, and I have F of X right here, so make sure you change that T to an X, and that's going to be my equation. So now part B, state the solution to the equation P of X equals F of X rounded to the nearest year. Interpret the meaning of this value with the given context. That's huge. When it talks about the context, it means in your final answer, you're going to explain the number that you get in terms of palm trees, flamingos, years, everything that we're talking about in this question. Okay. Now, nowhere in this part B does it tell you to do it algebraically, and that's also so important. This comes up on the exam so much. If you tried to solve this algebraically, you'd be at it for a minute. It is a very hard equation to solve algebraically. I don't know about everybody watching this video, but for my students, we've never solved something like this algebraically, okay? So please don't try to. It's going to be really hard. You are going to solve it graphically. So to do this graphically and to find where this equation is equal to this equation, we are going to graph and find where they intersect. Okay, so to graph each of these, I'm going to go to my y equals, clear everything out, and type in both equations at the same time. So 1 into your y1, 1 into your y2. So if you need a minute to do it, just pause the video. I do want to remind my 83 calculator people, when you have more than one thing in the exponent, you have to put it in parentheses. See how this one, there's just an x? You wouldn't have to for that one, but since this one has more than one thing, you have to tell your calculator that whole thing is the exponent. That's for my 83 calculator people. Just double checking I typed everything in right. We are good to go. So if you hit graph right now and you're still on your like Zoom 6 10 by 10 window, you're not going to see anything. So I need to zoom out. I talked about it in a previous video, but there is a thing called Zoom 0. It just gives you like not a great window, but it gives you an idea of where your graph is. We already kind of knew it was going to be around 500 and 200 based on the starting amounts, and I'm seeing that now. But once you get to the Zoom 0, you can like fix your window, make it a little bit nicer. Now your x. For my, oops, going back to my window, sorry, hit clear. For my x values, remember x represents years. We do not have negative time, so I'm going to go from 0 to, maybe I'll just change this to 15 for now. Remember, this is just kind of a guess and check sort of deal. Your y-min, I'm going to start it at 0 as well. And this one says to go up to 700, and I think that looked good, so I'm just going to leave it as regular 700 because that Zoom 0 made it a crazy number. Okay, so with the window that I just made, I'm not seeing an intersection point. That's a problem. We have to find where they intersect, and if I'm not seeing an intersection point, obviously that's not going to work. So we have to go back to our window, actually looking at the graph. You can see they're going to intersect if they keep going more to the right. So I want my window to go more right, which is making my x max bigger. Again, we were just kind of guessing and checking. That's why I put a 15 there. Maybe I try 20, and 20 works. I do see the intersection point. We're good. So if you need the window again, here it is. Again, it doesn't need to be perfectly this. You could make your x max 25. You can make your y max 1,000. It's not an exact science. As long as you can see the intersection, you're great. Now, on my app, it doesn't do intersections the same way that yours does, so you're going to have to follow my words. To find the intersection point, you are going to have to press second, trace, choice 5, which literally says intersect, and then you have to move that little cursor over the intersection point and press enter, enter, enter. Okay, so I'm going to just sketch this to show all of my work. I'm going to say this is 500, and it goes like that. And I'm going to say this is 200, and it goes up like that. Yeah, oh, that was terrible, though. Maybe I'll fix that one. Went a little too fast. Whoop, there we go. So this right here, find that intersection point. Take a second to do it. Again, oh, maybe mine does second trace intersect. Yeah, it really does not. No. It says no intersections, which I don't think is correct. If yours is not exactly the decimal that mine got, it's again because mine's using the app, but you should be getting about 18. So do second trace. Like I said, move that cursor to the intersection point and just press enter 3 times. Your decimal might not exactly be this. I apologize if my calculator is not working great, but it did get me 18, and that is the answer. It says to the nearest year. This one does not bump that 18 up, so it is going to be 18 years, and that'll be your final answer. Now, to check. Gosh, every time I finish a question, I love being able to say to check. You can check most of the questions. You can take that 18. Remember, this is the rounded value, so it would be more accurate if you took the whole decimal, but you can take that 18 and plug it into each of your equations up here. So if I plug in 18 to p of x, it would be 500 times 1 minus 0.03 to the 18. This is what I get. When I do it for flamingos, f of x, it is to the 0.02 times 18, right? Boom. And again, I used the non-rounded 18. If you use the rounded 18, they'd be much closer, but you can see 288 and 286, they are pretty darn close. You're good to go, okay? Now, that is not the final answer to this question because remember, it said to interpret the meaning of this value within the given context. It's always very smart to go back up and make sure you've answered the question because I honestly thought we were done. I kind of forgot about that for a second. So you have to interpret what that means with the context of the situation. We already kind of talked about it. We just didn't write it out. We're going to say it would take 18 years. Right, we solved for years. That was the x value in this problem, and that's what I wrote was the x value. It would take 18 years. What did I write there? It's like an R and an S in the same letter. It would take 18 years for the number of palm trees to be equal to the number of flamingos. I apologize for my handwriting. It would take 18 years for the number of palm trees to be equal to the number of flamingos. And I do also want to remind you guys, yes, when you find the intersection point, it does give you x and y. We didn't write the whole point because it was only asking for where p of x equals f of x. And it even said like a hint to the nearest year, informing you that you only want to find the year. P of x equals f of x is kind of asking you like, where does y equal y? Or like, where are the populations equal to each other? You're not going to say at this population, you're going to say at this time in years. But then I interpreted it to finish answering the question and we are good to go. So the last question is a part 4. Part 4 is worth 6 points. So it's usually a pretty lengthy question. You can expect that. And this one was a trig graph. So here we go. It says the volume of air in an average lung during breathing can be modeled by the graph below. Using the graph, write an equation for n of t. So again, be smart. Make sure you use that n of t in the form n of t equals a sine of b t plus c. So if I have to write this equation, that means I need to figure out what a, b, and c are. T is a variable and n of t is a variable as well. So those are going to stay exactly what they are. But I need to solve for a, b, and c. There's a lot of details about trig graphs and I'm going to throw your way right now. A is the amplitude. So the amplitude is how far up and down your graph goes from the midline. The midline is C, and it is the number in the middle of your graph. And B is the number of curves you have between 0 and 2 pi, but that's really hard to see on this graph because I don't have 0 and 2 pi. So what we're going to use to find B is the formula that has B in it, which is period. And period is the length of one graph. If you did not follow all of that, listen to it again. All of that is so important and so detailed. So again, A is amplitude, C is the midline, B we're going to get from the period, which is the length of one curve. Okay, now there's a couple different ways to find these. For my people that liked to eyeball it, I'm going to show you that first. The midline is this line in the middle. I know that's a wild definition, but see how that line just kind of cut the graph in half? That is your midline, which is C. So when I look over here, it's going from 2,000 to 3,000, and there's 5 tick marks. So each tick mark is going to have to go up by 200. So it's like 2,200, 2,400, 2,600, 2,800, 3,000. So C is going through 2,400, so that means C is going to be 2,400. The amplitude is how far up and down you go from the middle. So it's going this far and this far. It is 2 boxes, but 2 boxes is not 2. The amplitude is going to be the total distance between 2 boxes. And since each box is 200, 2 boxes would be 400. So that's how to find A and C by looking at the graph. Before I move on to B, because I do think B is a little bit tougher, I'm going to show you another way to find the amplitude and the midline if that was like way like too much for you. So amplitude and midline have formulas. The amplitude formula is the y max minus the y min divided by 2. The midline formula is almost the same thing. It's just adding y max plus y min divided by 2. Now your y max is how far up the graph goes. So the y max is this number right here, which is at, oh my gosh, this graph is really little. I forgot, you can just zoom. It's at 2,800. The y min is going to be at this lowest value right here. that y min is at exactly 2,000. So I'm going to plug those numbers in. The y max is 2,800 minus the y min, which was 2,000, gives me 800. Divided by 2 is 400. You get 400 anyway. So that's A. C is the y max, 2,800 plus 2,000 divided by 2. When you plug that in your calculator, you will end up getting 2,400. So you have 4,800 on top, cut that in half, 2,400. So that's two different ways to find A and C. Hopefully that was not too bad, but I now have A and C. So A, when I'm done, is going to get plugged in right here. B, when I'm done, C, when I'm done, is going to get plugged in right here. Now to find B, again, what B is the number of curves you have between 0 and 2 pi. Usually when we're looking at a trig curve, we're looking at the interval from 0 to 2 pi. So if you saw like one sine curve, we would just say that B is 1. But this x-axis is not labeled to 2 pi, so it's not obvious to see what B is by looking at it. You have to use the period formula. The period formula is 2 pi over B. Now, because I'm solving for B, I'm going to be solving for this piece down here. That means I have to plug in for the period. To be able to plug in for the period, you have to know what period means. The period is kind of like, remember we talked about it in class, the period is at the end of a sentence. The period for a trig curve is at the end of the curve. So it is the length of one curve. So I'm going to kind of erase all of my marks because I've got a lot going on here and it's getting a little sloppy. The length of one curve. This is a sine graph. You can see right here it says sine. If you couldn't tell, you can always look at the shape of the graph. It's an S shape. So to finish one full S shape, it's going to go up, then down, then back up. That means this point right here is the end of the curve, and that length, right, the length of the curve would go from here to here, which is 5. So that means that 5 is the period. If 5 is the period and I need to solve for B, that means I'm going to plug in 5 for period and solve for B. So when you have a fraction equal to a fraction, to solve it, you need to cross multiply. I'm going to get 5B equals 2 pi. And then to solve for B, I'm going to get rid of that 5, which gets me 2 pi over 5. So now I have solved for A, B, and C. I just need to plug it into that final answer. So my answer in that format that's given to me up here is going to be n of t equals A was 400, sine of B is 2 pi over 5, t plus C, which is 2,400. And that's my answer. Now you do also have to double check your sign, whether it's a positive sine curve or a negative sine curve. See what's going up, then down, then up? That is a positive sine curve, so that means that this is going to stay positive. If your graph went down, then up, then down, you would have to put a negative in front of that 400. It doesn't happen in this case, but you always have to check for that. The other thing that you should do before even moving on to the next part is check this in your calculator. Guys, we have an equation. This equation should look like this when you graph it. So I'm going to go to y my equals. The other thing before I graph this real quick to remind you, this is in radians. So when you're graphing a trig graph, you need to be in radians. I am going to click mode, go down and make sure you are highlighted over radian. You probably are, especially if you've reset your calculator recently, but you've got to be in radian mode. Okay, so now I'm going to go to my y equals and type this in. So it's 400 sine of 2 pi over 5 x plus 2,400. Now the other thing you have to do when you are graphing this, pause if you need more time by the way, is change your window. But we have the window because the graph's already given to us, so I just have to match that window on my calculator. So the x min is going to be my smallest x value, which is 0. The x max should be my biggest x value, which is 5. There we go. My y min is the lowest y value, which is 0. The biggest y value is up here, 6,000. So change your x max to 6,000. Now, when you hit graph, you should be seeing an identical picture to what we have right here. And I am. So that means your equation is correct. If you plugged it in incorrectly, maybe like, I know this is silly, but I'm just going to show you. Maybe you accidentally put A in place of C. and you put C in place of A. So I put the 2400 in for A and the 400 in for C. When you hit graph, it doesn't look like that. This looks nothing like that picture over there. So that would be a big red flag to you that it's wrong. If it's not matching, it's not correct, okay? So now that I checked, we're good. We're gonna move on to the next one. I think we use this again, so I'm just gonna fix it. Okay, again, matched, perfect, great. Okay, on the back, that same lung, when engaged in exercise, has a volume that can be modeled by blah, where E of t is volume in milliliters and t is time in seconds. Graph at least one cycle, so one curve of E of t on the same grid as N of t. So basically, all it's telling me to do is graph this on the grid on the page on the front. So I am going to write some information about it first because we need to know some stuff about it. So if you remember from this question, it was very helpful to know the midline and then go up and down the amplitude. So for this one, the midline is this number here. C is your midline, and for this one, it's 3200. So the midline for this one's graph is going to go through 3200. I'm going to graph that right now and get it out of the way. 3200 is right here. Now from there, the amplitude is that number in front. So the amplitude is 2000. That means that from the midline, you're going to go up 2000 and down 2000 from that line to make the curve. So we'll do that in a minute, because you also need to know the length of one of your curves before you can start plotting some points. So it says to graph at least one cycle. One cycle means one curve. If you have to graph one curve, you have to know how long that curve is going to be. So I also need to find the period. Period is 2 pi over b. Remember, in the last example, we were solving for b. In this one, we know what b is because look at where b was up here. B was in the parentheses with the x. I know what b is for this one. It gives it to me. B is pi. So I'm going to plug in pi for b to find the period. It's 2 pi over pi, and I get that the period is 2. Now, I know we talked about it literally 2 minutes ago, but the period is the length of one curve. So that means that the period is going to end at 2. So your graph won't go over here at all. No, it's going to stay within that window of 2, 0 to 2. So the last thing we need to know is what kind of curve we are graphing. It's a sine curve and it's positive. So a sine curve makes that S shape. It's going to go up, then down, then up, just like the curve above, except it's going to be a little squished because the period is smaller. The period of the one that was given to us was 5. Our period for this graph that we're graphing right now is 2. It's of course going to be a little smaller. So I want my graph to, it has to go like this to make that positive sine curve shape. Sine curves start at the origin, but our origin has shifted up to the midline. So my origin is now technically here, and I need to go up to my amplitude and down my amplitude. So from 3200, I have to go up. Remember, the amplitude was 2000. So I have to go up 2000. From 3200 up 2000 is going to put me at 5200. So 5200 is going to be my next point. Now we do need to space this out nicely. So what I'm actually going to do before I plot that point is plot my end point. I meant to do that first and I totally forgot. So I started at this point right here. Now I need my end point. They're at the same level. So your end point has to be at 3200 and the period was 2. So your end point is going to be right here. So these 2 points, I'm just going to highlight them so you know what I'm saying. This one is here. This one is here. I've already plotted the beginning and the end. Now I just need to fill in the middle. So halfway between the beginning and the end is where it's going to hit the midline again. Halfway between 0 and 2 is 1. So I'm going to hit again right here to make that sine curve shape. Now is when I'm going to go up and down my amplitude. So halfway between is going to be right here. That's where it's going to hit the highest. Halfway between these is where it's going to hit the lowest. And again, my amplitude is 2000. So I'm going to go up 2000 from 3200, which is 5200, and it's going to be on this line. So 5200 is here, and I'm just going to erase this. I'm just trying to show you why I'm putting the points where I am. And then halfway between your 1 and 2 is where it's going to hit the lowest. I just plotted this point. Now I'm going down here to do this one. The lowest is going to be 2000 down from 3200, which is going to be 1200. So I'm going to go down to 1200. So 1200 is right here. That's going to be my lowest point. And I am now going to connect these. Connect, connect, connect. And remember, when you have more than, oh, sorry, dropped my pencil. When you have more than one curve on the same graph, you have to label. So this one should be labeled E of t. So I'm going to label it right now, E of t. Okay, now the last thing I need to do, actually before we do that, I want to check this one by plugging the equation into the calculator again. So when you plug this into your y equals, you should be seeing this graph. So I'm going to go to my y equals. I'm going to keep that one there for now, just so you can see in a minute. You're not sure if you're going to need it for the next part, so I'm just going to leave it. I'm going to type in this equation, 2000 times the sine of pi x. If you don't remember where pi is, it's second caret, like the exponent button, by the way. So pi x plus 3200. And I hit graph. Now, it did say to graph at least one cycle. You could have kept going. That's why it's showing more. But if you look on the graph, I'll try to, yep, I got it. Look at where that point that I just put is, where the two like intersect. Yeah, that's not great. But you can kind of see where they intersect. It's about right here. They are matching up quite nicely. So if you did continue the curve, it would just keep going. Like at 4 is where it would end. Halfway between those is where it would hit again. Halfway between that is where it's going to hit the top. Halfway between that is where it's going to hit the low. So it's that same pattern. Once you have one, you're good. You just got to keep like replicating that pattern. So this one will go up and down, then up, and then again. But you can see it's definitely matching up with that curve on the grid. So we are good, and I can see it in reference to keeping that first equation in there, which was helpful. Okay, so now we finished that one. I checked it. We're great. Everything's good, and I've answered the question. The last part says, how many times during the 5-second interval will n of t equal e of t? Now remember, this means intersect. So I want to know not where they intersect. You do not need to do second trace and figure it out. It just wants to know how many times. So if you keep drawing this, now the next point where it would end, because it's starting at 4 and the period is 2, is 6. But halfway would be 5. So it is going to hit here again. It's just going to go up in between them to here. That would be like the rest of what curve could fit. And then it only wants it from 0 to 5. It doesn't care about anything after 5. So I'm going to count how many times they intersect between 0 and 5. So I see that they intersect here. I'm highlighting in yellow. Here, here, and here. So those two graphs intersected 4 times between 0 and 5, which is again what it was asking during the 5-second interval. So the answer is just 4 times. You don't have to figure out what they are. How many times means how many times did they intersect. Now, even if you had a really hard time graphing this one, you can answer this last question. So sometimes you can answer the part C without the part B. Like, never ever give up. This one, if you look at the graph, I still have it open. Look at my calculator. You can count how many times they intersect. I'm going to point them out. There's this one, 1, 2, 3, 4. I can count on the graph just by plugging it into my calculator and see where they intersect 4 times. So you made it through the June 2023 exam. Congratulations. Good luck studying. You've got this. You're going to do great.